Welcome back, viewers. This is Ijaz Khan here to talk on operations research or business mathematics, one of the important chapter called transportation problem. Friends, transportation problem is one of the subclasses of LPP, linear programming problem. Now we need to understand what is this transportation problem is. See, generally transportation or transport means transporting number of goods from various origin to various destination. Now what is this origin? Origin means starting point from where the transportation starts. For example, origin is Bangalore and the destination is Delhi. So Bangalore is the starting point from where production will dispatch and it reach finally to the Delhi, that is final place, final destination where there is a demand for a product. Transportation, very simple, transporting the goods from one place to another place, from various origins to various destination, called as transportation. Now here there is another word attached to transportation. Transportation problem. The problem related to transportation. Here the objective of problem is to maintain the cost. Transporting the number of goods, homogeneous commodity from various origin to various destination at a minimum cost is called as transportation problem. In simple, you write the meaning of transportation problem like this. Transportation problem is one of the subclasses of linear programming problem where there are number of origins and number of destination to supply from origin to destination with a minimum cost. The objective of transportation problem is minimum cost is the objective behind this. So transporting various goods, homogeneous commodity from number of origins to number of destination is known as transportation problem, my friends. Friends, under this transportation problem, there are various techniques or methods, I can say. The first one is NWCR. The first method is NWCR. What is this NWCR stands for? It is abbreviated as Northwest Corner Rule. NWCR, Northwest Corner Rule method, my friends. The next one is MMM or LCM is abbreviated as matrix minima method. Matrix minima method or least cost method. I have explained you this all points. There are three different methods and one more called modification techniques or method. So the next one is third one, VAM. VAM, Ogle's appropriation method. Ogle's appropriation method, right? And the last one is Moody. Moody means a modification. Here the Moody stands for modification. VAM stands for Ogle's appropriation method. Next, MMM, matrix minimum method. LCM, least cost method. Least cost method. It is also known as matrix minimum method. Likewise, we have NWCR, Northwest Corner Rule method. Friends, under this chapter, we are going to study 4 different methods of transportation problem. Number 1 is Northwest Corner Rule method, and the second one is matrix minima method, and it is also known as least cost method, and the third one is WAM method, Ogle's appropriation method, and the fourth one is it is approximation method, and the fourth one is it is additional method or techniques. I can say it is MODI, not MODI, it's MODI, modification method. To modify, we apply this modification to northwest corner rule method, and MODI can be applied for least cost method or matrix minimum method, and the MODI can be applied for Ogle's approximation method. Ogle's approximation method. These are the methods we are going to study. Now the first one is northwest corner rule method. I'll solve some of the problems on NWCR. Balanced transportation problem, unbalanced or imbalanced transportation problem, then maximization problem, minimization problem. So there are further 4 types of northwest corner rule method. Balanced transportation problem, imbalanced transportation problem, then maximization transportation problem. So under northwest corner method, I am going to deliver 3 different techniques further. Likewise, similarly under matrix minimum method, under WAM method, right? So MODI, it is a modification of northwest corner method. MODI is a modification of matrix minima or least cost method. MODI is the modification of WAM method. When there is a basic feasible solution in the problem. If it is not basic feasible solution, we cannot proceed with modification. The initial solution should be basic feasible solution or degeneracy. I will tell you what is this BFS, basic feasible solution, or degeneracy, not basic feasible solution, and degeneracy. Are you getting me? So this is what the things which I am going to deliver in this lecture, right? Okay. Next, moving further to, before that, we need to understand the formulation of transportation problem, mathematical formulation of transportation problem. Until unless we go through mathematical formulation of transportation problem, we not proceed, we cannot go with the practical one. We may not understand at all. What is this destination? What is this origin? Okay, what is this Xij, Cij, what is Ai, what is Bj, right? What is this Ai equals to Bj, and what are the rules and regulations of these all transportation problem? It means if you want to solve the problems on transportation problem irrespective of northwest corner method, matrix minima or least cost method, or Ogle's appropriation method, or last one is a modification techniques, you need to understand mathematical formulation of transportation problem. Friends, let us move further with the mathematical formulation of transportation problem. See, under this one, mathematical formulation, of transportation problem, right? So this is the heading and how it looks like. I will explain you here. Please pay your attention, try to understand. This is origin side, origin, starting point of transportation, where it begins, right? Fine. Next, this column wise destination, I write. Origin, destination is very important in the transportation problem. Okay, I just explained you what is this transportation as well as transportation problem. Now I am explaining you mathematical formulation of transportation problem to understand practical problem on the same, right? So let us consider destination 1, destination 2 and destination 3, likewise destination n, and this could be our capacity. Capacity, origin means capacity, how much capacity you have, how much capacity particular origin has, right? So such capacity will be dispatched, right? Fine. Likewise, number of origin 1, origin 2, origin 3, and here we consider origin m, right? Now here it is demand. Demand of the destination is also important. Demand of the destination and capacity of origin. Capacity of origin. If capacity is 100, demand is 80, yes, it can be dispatched. If demand is 200, capacity is 100, we cannot meet our demand. It means there is a huge demand. There must be production. There must be production so that it can be meet demand. Right. Likewise, I just give you the detail of mathematical formulation. See here I have written origin. There are several origins. Namely origin 1, origin 2, origin 3. Likewise infinity m and demand for the destinations. And this side destination 1, destination 2, destination 3. Likewise n infinity. Destination and capacity of destinations, right? Here I write cost 1, cost origin 1, destination 1. So likewise cost origin 2, destination 1, cost origin 3, destination 1, cost origin m, destination 1. So likewise you write the cost of both the side AIBJ. I will tell you what is this AIBJ. So further I write cost. This is 1, 2, 3, 2 and M2. Fine. Next the third one is cost and cost. This is 1, 3, 2, 3, 3 and M3. Okay, then the cost and cost. Here it is 1n, 2n, 3n, mn, right? Because here it is m. Fine. Now let us consider capacity is A1, A2, A3, A4. Let us consider the demand. Here is 1, B1, B2, B3, B4. See the condition. AI must be equals to BJ. Fine. This is summation AI equals to summation BJ. What is this AI? What is this BJ? I will explain you. Don't worry at all. This is our mathematical formulation of LPP. See, if you are a operations research student, irrespective of course, irrespective of semester, you need to understand the formulation of this one, transportation problem. Which formulation? Mathematical formulation of transportation problem. Unless and until you go through this mathematical formulation and the basic rules and regulations how to proceed the transportation problem, you may not proceed at all. So please have a look here. That's basic mathematical formulation so that you can easily proceed with number of problems of your irrespective of the questions. Fine. Now, what is this C? C, I said the cost. What is next? The transporting of the units. We have to consider it is X11, X21, X31, X M1. Same you write. The transporting number of unit from number of origin to number of destination is called as Xij. X12, X22, X32, Xm2, right? Likewise X13, X23, X33, Xm3. Right? Likewise here X1n, X2n, X3n, Xmn. Right? So this is what I will tell you. Don't worry. What is Cij? What is Xij? What is this origin? What is this destination? What is AI? What is BJ? AIBJ? AIBJ? I will tell you. Don't worry. I will explain you. in a proper manner so that you can easily understand this formulation of LBP. Once you understood this formulation of LBP, we'll proceed with the problem of transportation problem. The first problems will be on northwest corner rule method or techniques. Under this northwest corner method, first I will solve balanced transportation problem, then imbalanced or unbalanced transportation problem, then maximization of transportation problem. So three different types of transportation problem you may be asked in your examination or your in your business. You may apply this concept to minimize the transportation problem so that you maximize the profit of the organization. This is what the intention behind transportation problem, right? Likewise, next I will start with matrix minima method or least cost method. First I will explain you this, then this, and then last one, modification method of transportation problem, right? If you have any doubt, you may ask me by commenting in the comment section. You please comment me so that I'll improve my delivery of talk, or I will explain you whatever problem you are facing here, right? You might not get this, right? I will explain you, don't worry, right? Now the question arises here, what are these abbreviated ones, the short form I have written on board. The first one I write M. You need to understand what is M. You may be asked the question, what is M? M means what? M is nothing but origin. M is nothing but origin. It is nothing but rows. Where you could find origins? Row wise. All rows are nothing but origins. Right? Fine. This is nothing but the origin. Origin, this is origin 1, origin 2, origin 3, and likewise origin M. Right? These are the starting points of transportation problem. Fine. Next, N. N stands for destination. N stands for destination. You could find it in columns. In columns, rows, columns. So these are the columns. Column 1, column 2, column 3, column 4. Right? So here it is destination. So this is destination. Destination 1, destination 2, destination 3, destination 1. These are the final places. You might consider this is Bangalore, this is Delhi, this is Punjab, okay, this is Haryana. So likewise, this is other city of India like Mysore, like Mumbai, like Pune. Okay, various origin and various destination. Starting point is called as origin, and the final place where your goods must be reached is called as destination or final place, my friends. Now here M stands for origin. M is nothing but origin. N is nothing but destination. Origin is nothing but rows. You could find in number of rows, and destination you could find in number of columns. So these are the rows: row 1, row 2, row 3, row 4, column 1, column 2, column 3, and column 4. Likewise, you may understand. Next, CIJ. What is CIJ? Cost of transporting number of units of a product from various origin to various destination, right? The cost of transporting number of unit from origin to destination, or ith place to jth place, ith place to jth place, right? Number of origin to number of destination is called as CIJ. Now, what is XIJ? XIJ, quantity transported from ith place to jth place, ith place to jth place, origin to destination. Okay. Now, what is AI, quantity of commodity available at origin. What is this BJ? Quantity of commodity quantity of commodity available, BJ, quantity of commodity demanded at destination. This is the abbreviation of M stand for origin, M destination, CIJ cost of transporting number of unit of product from various origin to various destination. It is nothing but ith place to jth place. XIJ quantity transported from ith place to jth place. AI quantity of commodity available at origin, and BJ quantity of commodity demanded at the destination. This is all about the theoretical aspect of transportation problem, my friends. Right? If you have any query, any question, you can ask. Then my next video will be on northwest corner rule method. First problem is balanced transportation problem. Then the second one is imbalance or unbalanced or not balanced transportation problem. Then maximization of transportation problem. So likewise, I will complete this northwest corner rule method. Then I will start with matrix minima method or least cost method. Same three kinds of problem I will solve here. And then WAM method, the same three kinds of problem I will solve under WAM method. Then modification of this, and modification of this. This is what the entire chapter of transportation problem. Right? Please follow my series of lecture. This is the first lecture, then second lecture on transport. This one northwest corner method, third MMM or LCM, and fourth this one WAM, and the last one is MODI. Right? Thank you so much.